3.2 is on odds and probability. And probability we've already talked about. I'll just remind you from before. I don't know why I've written it again. I apologize. Probability is the mathematics of chance. It's how likely something is to occur. And oftentimes people equate probability and odds, say they're the same thing. And they're not exactly the same thing, actually. There's a subtle difference, but very important difference between odds and probability. So that's the main topic of this section. Before we get to odds, we're going to compare experimental probability and theoretical probability. So experimental probability is when you do an experiment, and then based on the results of the experiment, you calculate the probability. So here's the formula. The probability of an event A, is the number of times event A occurs divided by the total number of trials in the experiment. So number of A divided by number of trials. So let's say you had no idea what the probability is of rolling a 2 on a die, and you roll the die and you rolled it 600 times, okay, because you want to get really good results. So you roll it 600 times, that's the total number of trials is 600, and you roll a 2 198 times, let's say. So 198 over 600. You could divide both of those by 2, you get 99 over 300. You could divide those by 3, you get 33 over 100. So 33% is our answer. That would be our experimental probability. So I'll just leave you with that for a second as we go to theoretical probability. Theoretical probability is when you actually just think about a situation and you're able to determine the probability just based on math per se. So for example, if we consider the die, the example of rolling a 2, you don't need to do experimental probability. You know, well, let's show you the formula first. Here's the formula for theoretical probability. It's the number of outcomes favorable to A divided by the total number of outcomes in the sample space. So when you roll a die, how many outcomes are there in the sample space? The outcomes are 1, 2, 3, 4, 5, 6, so there's 6 of them. And how many of those outcomes I just said are favorable to A? In other words, how many of them are equal to 2? Just 1. So you get 1 over 6. This is theoretical probability. So which one do you like better, experimental or theoretical? Well, experimental is more fun. You get to roll dice and stuff. But theoretical probability is more accurate, right? If it's possible, you want to use theoretical probability. But sometimes you might not be able to figure out. Like, it might be something that's really not that well known. Some I don't know, imagine there's some machine or some game that you're not familiar with and you're trying to figure out the probability and you don't know all the different outcomes and everything. So then by using the experimental probability you could get a sense of it. So there you go, the difference between experimental probability and theoretical probability. We'll mostly be talking about theoretical probability in this chapter. Alright, at long last we get to odds. And odds express a level of confidence about the occurrence of an event. So it's how confident you can be about something happening. The odds of a 2 showing up on a die are, and you're probably saying to yourself, well, we already did that, it's 1 over 6. But that's actually not the odds of a 2 showing up. I'll tell you what it is in just a second. It's usually expressed in ratio form, like 4 to 5, but you could also express it as a fraction, like 4 over 5. There's two types of main things we do with odds. One is odds for, which are also called odds in favor of. And this is the ratio of the number of favorable outcomes to the number of unfavorable outcomes. So here's the distinction. So let's go back here, and if we look at this 1 over 6, this 1 was the number of favorable outcomes, and this was the total number of outcomes on the bottom here. So that's why it was 1 to 6. But if we look at odds for, and let's consider our die again, let's say you want to get the number 2 on a die, just like we did up here. So it's the ratio of the number of favorable outcomes. So just like before, the number of favorable outcomes was 1. But this time, the number is not the total that we're comparing it to, it's the number of unfavorable outcomes. So when you roll a die, and if you're hoping to get a 2, how many unfavorable outcomes are there? There's 5. There's 1, 3, 4, 5, 6. That's 5 numbers. So the odds for getting a 2 when you roll a die are 1 to 5. And if you look, that's different because there we had 1 over 6, or 1 to 6 if you want. Here we had 1 to 5, or 1 over 5. Probability 1 to 6. Odds 1 to 5. So you'll notice that this fraction up here, this is a part to whole fraction or ratio, right? You're comparing the part to the whole amount, the total number of outcomes. This is a part to part ratio. Remember this from grade 8? You're comparing the part which is the favorable outcomes to the part which is the unfavorable outcomes. So you have to be careful. This we kind of, I don't know, for myself, I kind of get caught sometimes always thinking of it as probability with the whole, where you're comparing it to the whole, but that's not the way it works with odds. You're comparing part to part. The formula for odds 4 is, the odds 4 is equal to the probability of A happening to the probability of, remember what this is? This is the complement. Remember what the complement is? It's the elements that are part of the universal set but aren't included in A. By the way, I forgot to say, when we back here in theoretical probability, when I talk about the total number of outcomes, this is assuming that all outcomes are equally likely. That's the only way you can use that formula. Okay, odds against, very similar. This time it's the ratio of the number of unfavorable outcomes to the number of favorable outcomes. So you can see all you've done is taken this ratio and turned it around. So if you want to know what the odds against getting a 2 on a die are, you compare the number of unfavorable outcomes. Well, there's 5 numbers on the die which are not the number 2, so those are the unfavorable outcomes. And you compare that to the number which are favorable, and there's only one which is favorable. That's the number 2 itself. The odds against getting a 2 are 5 to 1. And the formula is just like this one, except as you'd expect probably, it's the opposite way around. You have the complement on top and the actual event you're interested in on the bottom. If there's even odds, what this means is when the odds for and the odds against are equal. So we would say there's a 1-to-1 odds. This is like when you flip a coin and you ask, what are the odds of getting heads when you flip a coin? Well, it's 1-to-1, right? There's a 1 in 2 chance for probability of getting heads, but there's a 1-to-1 chance for odds when you're talking about flipping a coin. Okay, let's try a few questions here. Bailey chooses a card from a standard deck. What's the probability that she picked a face card? So remember, the face cards are Jack, Queen, King. And remember that you have each of those. You have those in your hearts, you have those in your diamonds, you have those in your spades, and you have those in your clubs. So you have 4 suits. Each one of them has 3 face cards. So that's 12 face cards total. And total number of cards in a pack of cards is 52. So your probability, remember this is a part to total or part to whole fraction. This up top here is the part we're interested in. These are the favorable ones. This is the whole amount, all the cards in total, so you get 12 over 52. If you put that in lowest terms, you can divide them both by 2 to get 6 over 26, divide by 2 again, you get 3 over 13. So there's the probability in lowest terms of picking a face card. Now, if you want to know what the odds are in favor of picking a face card, okay, so what you're going to do for that is, first of all, you're going to think of what are the favorable outcomes. How many favorable outcomes are there? Well, we already talked about that. There's 12 favorable outcomes. And we're going to compare that. I'll do it in this form because that's how we usually do odds. We're not going to put 12 to 52 because we're going to have a part to part here, right? This is the favorable part, and here we have to put the unfavorable part. So how many unfavorable cards are there? If there's 52 cards total, 12 are favorable. How many are unfavorable? 40. So your ratio is 12 to 40. Put it in lowest terms, you can divide them both by 4, you get 3 to 10. This is the odds in favor of picking a face card. What are the odds against picking a face card? Well, this time you do the same sort of thing, but first of all you put the unfavorable amount, which is the 40, then you put the favorable amount, which is 12. Put it in lowest terms, it's always going to be just the in favor one reversed, so it's going to be 10 to 3. Okay, so make sure you're clear the difference between probability and odds, very important. Research shows that the probability of an expectant mother selected at random having twins is 1 to 32. 1 over 32. 1 in 32 chance of having twins. What are the odds in favor of an expectant mother having twins? So again, This is the part. This is the favorable, and this is the total. What we want to do is we want to do a favorable to an unfavorable ratio. Okay, well the favorable is no problem. We have it right there. The favorable amount is 1. What's the unfavorable amount? Total there's 32. One of them's favorable. How many are unfavorable? 31. So the odds in favor of having twins is 1 in 31. What's the odds against having twins? We'll just switch them around, right? So it's going to be 31 to 1. A computer randomly selects a student's name to win a gift certificate. The odds against this selected student being male are 57 to 43. What's the probability that the selected student will be male? So again, this is odds against. So 57 is the unfavorable. These are the favorable outcomes. And now to do probability that the selected student will be male, we want to do a favorable over total. So favorable is the 43. Those are the ones that are when the male gets chosen. And the total, well, you'd add the unfavorable and the favorable together, you'd get 100. So it's 43 over 100, or if you want, 43% chance that a male student will be selected. I think the most important thing today is that you really get this concept that probability is favorable over total, odds in favor is favorable to unfavorable, and odds against is unfavorable to favorable. If you remember that, I think it really will help you get some of these questions if you get stuck. A group of students have created 2 dice games. The odds against winning the first game are 5 to 2, and the odds for winning the second game are 3 to 7. Which is a better game to play? Okay, well let's see, I don't know, let's see what the probability is of winning both these games. Okay, so the probability of winning, I'll put P winning, the probability of winning game A. So to get the probability of winning, remember, we need the favorable divided by the total. And if you look at game A, it gives us against, the odds against. So if it's odds against, then this one's unfavorable, the first number, and this second number is favorable. So favorable would be 2, and total, you would add those two together, 2 over 7. There's a 2/7 chance of winning game A. Now, if we want to know the probability of winning game B, again, you're going to do favorable and you're going to divide by total. So let's see the odds they tell us this time. Okay, this one says odds for winning the second game. So if it's odds for, then that means the first number is favorable and the second number is unfavorable. And what we want to do is put favorable, which is 3, over total, and the total would be 10. So here's your 2 probabilities of winning. One probability is 2/7, the other one's 3/10. We want to know which one's the better probability, because that would, I would suggest, make it a better game to play. So which one's better? Well, there's different ways you could do that. You could turn these both into decimals, divide 2 divided by 7, divide 3 by 10, and compare it that way. You could do get common denominators. Let's do that. Let's get the same denominator in both. So lowest common denominator of 10 and 7 is 70. What do you multiply 10 by to get 70? By 7. So do the same to the top. 3 times 7 is 21. We want to get 70 here too. What do you multiply 7 by to get 70? 10. So multiply the top by 10, you get 20. Great, now we can actually compare these things. The probability of winning game A is 20 out of 70. The probability of winning game B is 21 out of 70. Which game is more likely to be won? This game right here. Game B is slightly better. If you were to play 70 times, you'd expect that you'd win 1 additional time if you played game B. Okay, so one small concept in today's class, the difference between probability and odds, but in my opinion, a rather tricky concept. So be careful with it.